In Unit 13, we're going to look at the relationship between work and energy. Now, we haven't talked about energy in a while, but you guys should remember that energy is the ability to do work or cause change. And we did focus on thermal energy earlier in the semester. Remember, thermal energy is the energy of particles. And these are the particles that make up matter. So when we take a glass full of water, the molecules of H2O that make up water, those things are in constant random motion. They can twist, they can rotate, they can vibrate, and that gives them energy. If we threw more water in the glass, it'd have more energy. If we took some out, it'd have less energy. If we heat the water up, it would gain energy. If we cooled the water down, it would lose energy. But thermal energy is the energy of particles, atoms, molecules, those things. And it's, depends on temperature. It depends on mass, and it also depends on the type of matter. So that's a T, type of matter. And you guys remember that you can actually calculate the thermal energy gained or lost by an object by taking its mass times its specific heat times its change in temperature. So the more matter it is, the higher its specific heat, the greater heat is going to transfer into or out of it for a given temperature change. So thermal energy is the energy of particles, but we're more interested in this unit in mechanical energy. Mechanical energy is the energy of objects. Okay? This is different because particles make up objects. If you were to take a piece of steel and put it in a fire, it would gain lots of thermal energy. It would gain enough thermal energy to start glowing in the dark, but it wouldn't have gained mechanical energy. However, if you were to take that piece of steel and throw it across the room, that act of throwing it imparted some mechanical energy to it. We consider this the sum of an object's kinetic and potential energy. Now, we need to take a little bit of time to think about what those two words mean. Okay? Kinetic energy is the energy an object has because it's in motion. Potential energy is the energy an object has because an external force is acting on it. So let's look at that in a little more detail. So kinetic energy is energy due to motion. And like all energies, it's measured in joules, and we can calculate kinetic energy. Ke is equal to 1/2 mv squared. So if I have an object who's got a mass of 2 kilograms and it's moving with a velocity of 4 meters per second, then its kinetic energy is equal to 1/2 times 2 times 4 squared. Now remember that square is the first thing, exponents first, so I have 1/2 times 2 times 16. Half of 2 is 1, so I just get 16. Now we took kilograms times meters per second squared, so meters per second again, which is a kilogram meter squared per second squared. We give that its own unit. We call that a joule. So 16 joules of energy. So a kinetic energy, energy due to motion, the faster an object goes, the greater its kinetic energy. The more mass an object has, the greater its kinetic energy if it's in motion. Potential energy, I have a lot of people tell me, is the energy that something has when it's at rest. That's simply not the case. Potential energy, this is energy due to an external force acting on an object. Now, we tend to think of gravitational potential energy, but there's also elastic potential energy. So if you imagine a rock on top of a cliff, okay, there's a force of gravity outside of the object that is acting on it and wants to pull it to the ground. Okay? Because it can fall, it has that potential. So gravitational potential energy is energy due to an object's position and gravity. Okay? So when I say due to position, it matters where this thing is. If this is way up at the top, then it's got more potential energy than if it was just down here. And if it's on the ground, you could even argue that it doesn't have potential energy there. It can't fall anymore. Even though the force of gravity is still acting on it, it's now got the normal force balancing that force. So, potential energy is due to an external force acting on an object. If there's going to be potential energy, then some outside force needs to be pulling, and it needs to have the ability to cause a change. So, gravitational potential energy is energy due to an object's position, specifically height, and gravity. And we can actually calculate gravitational potential energy. Gravitational potential energy is just given by mass times gravity, the acceleration due to gravity, times height. Now what we have then is kilograms times the acceleration, which is meters per second squared, times height, which is in meters, so that's still kilogram meters squared per second squared, and that's still a joule. Okay? So if I had a 10 kilogram boulder 2 meters high, 10 kilograms times 2 meters high times 9.8 meters per second, the acceleration due to gravity, then I would have 196 joules. Okay, so a 10 kilogram boulder 2 meters in the air has 196 joules of potential energy. There is one final form of potential energy I want to mention, and that form of potential energy is elastic. Okay. Elastic means stretchy, and so generally this is the energy stored in springs. Okay. When you stretch a spring a little bit or compress a spring a little bit, you know it's got the ability to cause change. Dart guns use springs, lots of things use springs, a car uses springs. So energy stored in a spring is called elastic potential energy, and we're not going to go into how to calculate it, but if a spring was squished down into a smaller spot, then it's storing energy, and the energy that it has can be gotten back out. It has the potential to cause change because there's a force in the spring pushing up, and it can cause a change and move through a distance. So kinetic energy, energy of motion; potential energy, energy due to an outside force, depends usually on position as well. And then there's also thermal energy, which is the energy of the particles. But kinetic and potential and mechanical energy, these deal with the whole object, not the particles that make it up.